Uh, Let us start with the fourth session of lecture in AECS. So yesterday we had started and we had seen the first part of the first topic, that is battery. Today we will be finishing it. This first topic will be finished today, and we will start with the second topic, that is the charging systems tomorrow. So as per as your syllabus, the content is like this: principles and construction of lead acid battery, characteristic of batteries. So lead acid battery we have seen yesterday. Little bit of different types of. So there are four stages: charging, discharging. Then load was being supplied with some kind of current, and there was a gassing stage. So all these four stages you have to explain when any battery is asked. Then you have to talk about the support, you have to talk about the core, you have to talk about the electrode, and some materials are deposited on the electrode. So when we do the last topic today, that is NiCad battery, that is alkaline battery, then you'll understand more about battery structure, what is the difference between lead acid battery and alkaline battery. You'll come to know about it. So we are in the middle of the second topic, that is the characteristics of battery. So I will repeat this slide. So up till this we had done. So there are actually three main battery characteristics in battery rating. They are all actually discharge characteristics. So that's what I put some star, because this are very frequently asked question. That is, what are the three different battery characteristic, battery rating or discharge characteristic. So you have to draw this diagram first, and you can see there are mainly three types of discharge characteristic. The first characteristics is the longest. So y-axis is the state of charge, how much charge is remaining in the battery and how it is getting depleted or reduced. So x-axis is the time in hours. So you can see this characteristic which is discharging for a long period of time. So that period of time is 20 hours. And I told you yesterday that 12 volt is the battery for Bosch, and inside that there are six 2-volt batteries. So there are six batteries, each having 2 volts. They are connected in series, so they are creating the 2 volt. So when the batteries are fully charged, this will be giving you 2 volt each, and total of 12 volt we will get. When the battery is discharged, at that time battery voltage will be 1.75 volt. So these are very important details you must remember. In yesterday's slides also you can find that. So all the previous slides, all the previous lecture YouTube videos, all are uploaded in your Google Classroom. Please check that. Today's lecture also will be uploaded by 3 p.m. So please check that, and all the PDFs you should download as soon as possible and keep with you lecture wise. So keep making a database for this subject. So in the three discharging methods, we are first finding the first discharging method is called as simple ampere hour discharging. So ampere into hour. So for 20 hours, if the battery is able to give 2.2 ampere. So whenever I'm saying battery, we are talking about 12 volt, the complete setup. And inside that 12 volt, there is 6 small batteries of 2 volt each. So whenever I'm saying current capacity 2.2 ampere for 20 hours is given by all 6 batteries together. Okay. Then 2.2 ampere into 20, if you multiply, it will be 44 ampere hour. So ampere hour is a power rating of the battery. How much ampere current for how many hours? If you multiply that, you'll be getting the first rating of battery, that is called ampere hour. And there's the longest rating. Second rating is called as reverse capacity or reserve capacity, which is also called as RC, as you can see below, reserve capacity. So this is actually testing if the battery can give out that current is 25 ampere for 60 minutes. So if a battery can give us 25 ampere for 60 minutes, then we say that it is having good enough reserve capacity, and there is a temperature mentioned here also. The temperature is 25 degrees centigrade. So how much is the current for how much time and at which temperature? These three are the very important details. And after that, again, each 2 volt battery comes to 1.75 volt. And third case is for cold starting. So you can check here, as temperature is reducing, the requirement of power is increasing. So yesterday we have seen the graph that cold starting means when the ambient temperature is very cold, at that time we have to supply more power for the car to start, and the battery will be supplying that power. So what is this thing called cranking amps? What is it called? It just checks in 1 minute how much maximum current the battery can supply. So 170 ampere is that current. So you can check that the discharge is very fast. So within 1 minute, the battery is falling from 2 volt to somewhere it was not 1.75. It was somewhere around 1.47. So for core cranking amps, just check how much is the discharged battery voltage. It was around 1.47 volt or something. You can find it in yesterday's slide. So this is a third type of discharge, and which is the fastest discharge. In 1 minute, 170 ampere current the battery has to supply, and within 1 minute the battery will be discharged from the fully charged state of 2 volt. So these are three very important discharge characteristics or battery rating, and you have to draw this graph and explain it. So I'll give you a gist of it. Gist means kind of a summary. So ampere hour means how much constant ampere current the battery supplies for 20 hours. For Bosch battery, it is 2.2 ampere for 20 hours. Reserve capacity indicates that the time in minutes, so here it is 60 minutes, which battery supplies 25 ampere at 25 degrees centigrade and falls to 1.75 volt. So each 2 volt falls to 1.75 volt. Cold cranking current or cold cranking ampere CCA indicates the maximum battery current at 18 degrees centigrade or 0 degree Fahrenheit for a time of 1 minute. So Bosch battery can supply 170 ampere for 1 minute when the ambient temperature is 18 degrees centigrade. So this is the gist, and from here we can find out some of the more specifications. It says that a battery for a normal vehicle that we are driving, it may be rated as follows. So 44 ampere hour AH, that is the first rating. 60 RC, okay, so it can give us 60 ampere current instead of 25 ampere. It can give us 60 ampere current for 1 hour, okay, and for at 25 degrees centigrade, and 170 ampere. I'm sorry, this is not 60 RC, does not mean 60 ampere. 60 RC means 25 ampere for 60 minutes, and 170 ampere CCA, that means 170 ampere is supplied for 1 whole minute, okay, when the room temperature or ambient temperature is 18 degree. So these three figures are very important. What does 44H means? 44H means 2.2 ampere for 20 hours. 60 RC means 25 ampere for 60 minutes, and 170 ampere means in 1 minute the battery can give 1 ampere. Figure in the left shows three different discharge characteristics of the battery and three different time span. So reserve capacity is the mid time span, ampere hour is the highest time span, and cold cranking is the smallest time span. So smaller is the time span, current supplied will be higher, that you can see. One more detail, a heavy duty battery will have the same ampere hour rating as its standard duty counterpart. That means heavy duty battery also will be able to give us 20 ampere for 20 hours, sorry, 2.2 ampere for 20 hours, but it will have a higher CCA and RC. So this is a very important thing. So heavy duty battery, the question can be asked, that is, it will also be supplying in this curve, that is 2.2 ampere for 20 hours, but this 25 ampere, that is RC, will be higher for heavy duty battery. This may be around 30, 40, 50 ampere, and this 170 ampere and lower temperature, that also will be higher. Maybe it is 200, 250 ampere in 1 minute for a heavy duty battery. So these two lines, one is purple, one is red. These are very important fundamentals. Through the thing you understand automatically, this thing should be in your mind. So heavy duty battery will have the same ampere hour rating, that is 2.2 ampere for 20 hours. No change in that, because this is the normal mode of operation of the battery, and for that the CCA and RC will be higher. So in case of RC, it will be higher than 25 ampere. In case of cold cranking amps, it will be higher than 170 ampere. So yesterday's slide and this slide, so yesterday's last slide, second last slide and this slide together, that is actually the material for battery rating or discharge characteristic. Thoroughly you should go through and remember. Battery maintenance is, this is not in your syllabus that way, but okay, I will be telling you, this is only a one slide material. So by far, the majority of batteries are now maintenance free. So previously, whatever battery they used to design, in that battery we had to put some distilled water or something time to time. But nowadays, whatever battery they are designing, they are maintenance free or very little maintenance is required for those battery. That's why present day battery we cannot repair. Once it goes bad, we have to purchase a new one. So for battery maintenance, what is it said? Battery little attention is required during the life of the battery. Little attention means regular maintenance is not required, but we can check. We can be on our toes and we can check how much the battery voltage, how much rating, and all those things. Whether the battery is able to supply initial currents or not, all those things we have to check. Earlier batteries and some behavior types do, however, still require the electrolyte level to be checked and topped up periodically. So for that electrolyte level, we had to put water. So we had to dilute the electrolyte because the water used to get evaporated in the previous type of battery. Nowadays, we have to just check the battery output. We won't have to open the battery and put water. All those things are not required. This is a very important thing. Battery posts are prone to corrosion. So the 2 points between which we measure the battery voltage, so positive and negative, that is called post, they are prone to corrosion. And hence, so some depositions we find there on the posts, and hence the usual service of cleaning with hot water if appropriate, and the application of petroleum jelly or so petroleum jelly actually makes the contact. Okay, and this terminal is to be some put some grease and all these things is still recommended. So though there are not required some regular kind of maintenance in case of present day battery, but we can check between the two posts how much is the voltage developed, whether 12 volt is there or not. All those things we have to check. And there is a charging mechanism for battery as well. So if the battery gets discharged, we can charge it, okay, to ensure that 12 volt is found between the positive and negative. So ensuring that the battery case and in particular the top remains clean uh, will help to reduce the rate of self discharge. Okay, so there is something called a self discharge. So if one car is not run for longer time, that time there is a possibility that the battery voltage between positive and negative terminal will fall below 12 volt, which is not expected. Automatically they get discharged because recombination takes place inside the electrodes, and the batteries will be discharged, so it will fall below 12 volt. That should not happen. So if we want to avoid that, we have to ensure that the battery case, particularly the top of the battery, they remain clean. This third paragraph is very important. What we have to see is the state of charge. So state of charge means how much charge is stored. That is the most important parameter in case of any battery. And in previous type of battery, when we could open the seal of the battery to put water and all those things, distilled water, there by using a meter called as hydrometer. I will show you the diagram of hydrometer later on. So it's like a thermometer kind of thing. You just have to dip the hydrometer into that hole, and it used to give some reading. And from that reading, we could interpret whether it is 0% SOC or 50% SOC. Ideally, it should be 100% state of charge. So when it is fully charged, battery is fully charged, 12 volt, at that time SOC should be 100%. So hydrometer is the instrument. You can write down in your notebook that hydrometer is the instrument which is just immersed into the liquid electrolyte in the battery, and from some reading obtained from that hydrometer, we could find whether the battery is having full state of charge or half state of charge or 70%, 30%, whatever. So there is a table, and from that table we can just check how much is the ion concentration and all, and how much is the SOC. So SOC is the main important thing for battery that we are looking for. So in general, SOC would not fall below 70%. So whatever happens, SOC should not fall below 70%. Otherwise, the battery is considered to be not functioning properly, as the sulfate on the plates can harden, making recharging difficult. Okay, so this is one very important thing, that there is called as sulfonation or something. So that is a negative thing, that is a degenerative process that should not happen. If that happens, then SOC falls below 70%. Okay, so in general, SOC should not fall below 70% for long periods, as the sulfate on the plates can harden, making recharging difficult. So if there is this sulfating at that time, connecting the clamps for recharging the battery becomes difficult. So that's why we have to keep the battery clean, and we have to keep the posts. Post means while the charging the battery, we connect the external clamps on these posts, and then we charge the battery. Okay, so but if there is sulfate deposition at that time, charging the battery becomes difficult. That should not happen. Last thing, if a battery is to be stored for long time, that means more than 2 weeks, the car will not run. In that case, it must be recharged every so often to prevent it from becoming sulfated. So if we want to avoid the sulfation at the time, we have to keep on charging the battery every 2 weeks. Recharge every 6 weeks is reasonable suggestion. That means in 6 weeks you must drive the car. Every 6 weeks you must drive the car for some 5, 10, 15, 20 kilometers. But every 2 weeks, if you are running the car at least, this is very good. So these are some battery maintenance things you have to remember while using. Then again, coming a very important topic from your syllabus, which is called as charging of the lead acid battery. So battery maintenance is a very important question. Lead acid battery construction is an important question. And the first slide, yesterday's first slide, that what all work the battery does, that is also a very important question. And now we are coming to this topic, that is charging of the lead acid battery. So sometimes charging happens normally. Okay, we connect the external 12 volt another battery to this, and we transfer the charge. That is a normal process. But there is rapid charging that also might happen. So let us check why charging is required, when charging is required, and how to do that. So star means in any slide, this slide is important for exam. So this is a direct question. Be careful. So the charging recommendation of battery manufacturers vary slightly. Okay, not much, more or the less same type of charging capacity and charging process is recommended by all the manufacturers. So the following methods, however, are reasonably compatible and should not cause any problem. And those who were not there yesterday, the lines which are underlined, short questions can be asked from that. So we are having a quiz of 5 marks in every IA. So you must check all the underlined lines very properly. So the recharging process must put back some ampere hour capacity, that means some power, as was used on discharge, plus a bit more to allow for losses. So every battery is having some losses. So if we want X amount of charge actually to be put for battery to be fully charged, we do some X plus Y. That means some extra amount of charge also we put in the battery while recharging, because that will account for the losses. Okay. So it is therefore clear that the main question about charging is not how much, but at what rate. Okay, so we have seen for our mobile battery charger also, there are some chargers which are having 2 ampere capacity. In 15 minutes time they can charge your mobile perfectly. Okay, 100% charge. But there are some lower current range of the charge, that is 1 ampere or something. It might take 1 hour for your battery, that is mobile phone battery, to get charged. So it does not matter how much charge you have to do. So charge will always make the battery 12 volt. So how much is always the same quantity, 12 volt, but the rate of charging is very important. How fast you are replacing the lost charge in the battery, that is the question. saying there are three ratings. They are not how much, but they are at which rate battery is getting discharged. In case of ampere hour, it is 2.2 ampere for 20 hours. In case of RS, that is reserve capacity, RC, it is 25 ampere for 1 hour. Okay, there is a continuous, there is a constant. And in case of CCA cold cranking, it is 170 ampere for only 1 minute. So it is the rate of charge discharge which was varying in the previous case, and in charging also it is the rate of charge that varies in case of the charging. So how fast you can charge, that is the question. So this is a Bosch Media battery charger. So this is a Bosch battery charger. The image is found from Bosch Media, their website. In your book of Denton. So I told you previously that all these details can be found in the 5th chapter of Denton. The book is already shared with you. So you can start preparing today and finish preparing this chapter of battery. So keep my slides in front and then go through the book, or if you're just going through my slides, that also will be enough. So this is a battery charger, and there are certain charging methods which are explained. Let us study. So traditionally, battery should be charged at 1/10 of its ampere hour capacity and for about 10 hours or less. So if I'm saying ampere hour is 2.2, so it has to be charged with 0.22 ampere, okay, for 10 hours. So the battery should be charged at 1/10 of its ampere hour capacity for about 10 hours or less. So this is a very important line. This is assuming that the ampere hour capacity is quoted as 20-hour rate. So if it is mentioned as 2.2 ampere for 20 hour, that is the discharge. In that case, how the battery should be charged? Answer is it should be charged at 1/10 of its ampere hour capacity for about 10 hours or less. This is assuming that the battery is given for 20-hour ampere hour capacity. Not only, but only AH capacity is not always used nowadays for battery charging. So previously it was only 1/10 of its ampere capacity, but nowadays it is something else. Okay, another way is to set a rate of 1/16th of the RC. So it was having 25 ampere RC. In this case, that was discharged. So that battery, how it should be charged? It should be charged with a rate of 25 divided by 16 ampere uh, for 10 hours. That is another thing. And not only RC, CCA also can be used. So the final suggestion is to set a charge rate at 1/40th of the cold start performance figures for 10 hours. So these two paragraphs are very important and you have to understand that. So if it is a battery which is having 2.2 ampere for 20-hour rate for discharge, in that case, how the battery should be charged? That is 2.2 divided by 10 ampere hour capacity. How it should be charged from RC point of view? If the discharge was 25 ampere, then charging should be 25 by 16 for ampere for 10 hours. Then from CCA point of view, how it should be charged? If the CCA was 170 ampere for 1 minute, now it should be 170 ampere divided by 40 ampere. 170 divided by 40 ampere for 10 hours. So all the timer 10 hours, but one is for ampere hour charging, one is for RC charging, another is for CCA charging. Because previous day battery it was only ampere hour. Nowadays battery it is ampere hour, RC as well as CCA. All these three ratings we have to check, because it is not only about how much the battery should discharge over 20 hours, but how fast the battery can discharge if very high amount of current is required from it, maybe for 1 hour or maybe for 2 hours. In that case we call CCA. So all these three types of chargings are required. Okay, if a battery is already half charged, so how do we understand if the battery is half charged? We put that hydrometer in that battery electrolyte. We sense how much is the electrolyte concentration, and there is a table that if this much is the electrolyte concentration, this much is the charge state of the or SOC of the battery. So if a battery is half charged, already half charged, then the total charging time is more required to recharge the battery is another half. So his battery is half charged, then to charge it another half, that is from 50% to 100%, we won't have to charge it for 10 hours, but we will be charging it for 5 hours. If the battery is 70% charged, we will not require another 10 hours, but we will require another 3 hours. Okay, because it is 70% charged. So more 30%, 3 hours will be required for that. So this is a very important two paragraphs, and all lines in this slide are very important. So this slide number 4 in lecture number 4 is very important. More important lines about charging. So the recommended charge rates above are the best way to prolong the battery life. Now somebody can ask, sir, for ampere hour charging, you are saying that it should be 1/10 of its ampere hour, but I will charge with a rate of 1/5 for 10 hours or maybe for 5 hours. Can't I do that? Answer is yes, you can do. If you are using, instead of 1/10, if you are using 1/5, 1/5 is greater than 1/10. If you are using that rate for ampere hour, time required will be 5 hours. Okay, in that case, you can charge the battery faster, but that will harm or that will reduce the battery life. In my laptop, whatever I'm using now, I'll give you a very astonishing detail. I never charge my laptop more than 60%. Just check, I'm removing the battery because the battery is charged up to 60%, and this battery is being tracked by Microsoft. So I'm using Lenovo. I have very recently purchased this laptop, and I have connected it to Microsoft battery saving algorithm. So Microsoft is actually tracking my battery, the battery of my laptop, and they are always going maximum up to 60%. And after 60%, charging does not increase. Okay, and again it will come back to around 10%. As soon as it comes back to 10%, it again shows me there is another intimation that connect the charger. So the cycle for my laptop is not from 0 to 100, but the cycle for my laptop is 10% to 60%. This is a very important thing I have experienced. So the same thing they are saying, recommended charge rates above are the best way to prolong battery life. Somebody wants to say, instead of 1/16th RC, I will use 1/8th RC. You can do that. It will take half of the time to get that same RC. But in the prolonged run, you are actually losing the life of the battery. That is very important. They imply a constant current charging source. So there are actually two types of charging. One is constant current charging, one is constant voltage charging. We will see that, we will see the graphs. So they imply a constant current charging source. A constant voltage charging system is often the best way to charge a battery. So which are the two types? Constant voltage charging, constant current charging. And they are saying constant voltage charging system is a better way than constant current charging. Example, an alternator type of battery charger. So alternator is nothing but a AC generator. Alternator type of battery charger is held at a constant voltage, and the SOC of the battery will determine how much current will flow. So there is a automatic charging or very smart charging kind of mechanism we will be seeing today later on. That decides that if we want, so presently there is 60% charge in the battery, we want to go to 100%, we want the best prolonged life for the battery, then how much should be the charging rate by constant voltage charging? That will be decided by the smart charger. So an alternator type battery charger is held at a constant voltage, and the SOC of the battery will determine how much current will flow to prolong the life of the battery, to charge the battery sooner, and to take it to the 100% charging level. So any charger we connect to the mobile phone, any charger we connect to the battery is a wrong concept. So it is at which rate the battery should be charged so that we can get prolonged life of the battery. That is also we have to ensure. And I'll tell you, battery is a very sensitive device. When we are using laptop, when we are using car battery, we don't much care about it. Okay, but little care and little following the rules, and you will be getting battery never get corrupted, battery never give you a disrupted supply. Constant voltage is often the fastest way to recharge a flat battery. Flat battery means it is totally discharged. That means that 2 volt has become 1.75 volt. Then if you want to charge the battery, what they are mentioning is constant voltage charging is a better way than constant current charging. So two ways of lead battery charging. So there is a constant voltage charging, there is a constant current charging. It is said that constant voltage charging if less than 14.4 volt. Just see, this is the level in which the battery drops after cold cranking. So is less than 14.4 volt is used, then it does not cause excessive gassing. Okay, so if we are trying to charge the battery very fast, at that time gases created inside battery also will be more, and more is the gas created, more pressure it will create inside the battery. More pressure the gases create inside the battery efficiency and lifetime will reduce. So in constant voltage charging, if less than 14.4 volt is used, so this is the input charging voltage. So battery has got become flat. So each 2 volt has become 1.75 volt. In that case, we are using 14.4 volt across that total stack of 6 batteries, and we are charging it. Okay, so 14.4 volt is used to charge the battery up to 12 volt, and it does not cause excessive gassing. Somebody will say, sir, I want to charge it to 12 volt. So why can't I connect 20 volt? Or why can't I connect 100 volt DC? All these are DC, huh? There is battery. So why can't I connect 100 volt? You can connect 100 volt, but that will be producing excessive gassing inside the battery, and that will reduce the lifetime, that is corrode the components, and that will actually reduce the efficiency of the battery while discharging. So you have to remember 14.4 volt is the constant voltage what we have to apply to avert or to avoid excessive gassing. This method is particularly appropriate for sealed batteries. So generally we are using sealed battery only. Sealed batteries are maintenance free. So a combination of two charging methods is the best and fastest method, as we can see. So left side we can see constant voltage charging. So 14.4 we have connected, 14.4 volt we have connected between the two posts of the battery, and you can see this is the voltage graph, how the voltage is increasing. So initial voltage is not zero, initial voltage is around 2.5 volt. Okay, that is all 6 batteries stacked together, they are giving 2.5 volt. Then it's called a flat battery. Then we are giving 14.4 volt constant voltage to the battery, and the battery voltage is increasing, and after a certain time it is going up to 14.4 volt, but it will get saturated up to 12 volt only. Okay, and when the battery voltage is increasing, the battery current is actually decreasing. So initially the battery current is very high. When the battery voltage is very low, battery voltage is around 2.5 volt. At that time battery current is very high, around 20 ampere. So this is a graph you have to remember. This is constant voltage charging. So battery voltage is very low, battery current is very high. As the battery voltage starts picking up, at that time battery current also keep on reducing. So finally the battery voltage is very high. As you are giving 14.4 volt, it will also go to maximum 14.4, because I told you 12 volt plus some excess charge we input, so that it will compensate for the losses. Okay, so it goes up to 14.4, and the current also reduces from 20 ampere. Current reduces to very small rate. How much is the rate? So here this side is the current. Okay, so this current is, here it is 2.2, here it is 2.4. So this may be around this is 10, this is 2.2, I don't know. So this is 0, this 0 ampere current is said, this is 2.2. So between that, so maybe it's around 1.1 ampere current. Okay, so what is the starting of the charging current? Starting of the current is from 20 ampere, it is falling to around 1.1 ampere, and the voltage in the battery is growing from 2.5 volt and is going up to around this is the voltage axis. So left side is, okay, left side is the current axis, I'm sorry, left side is the current axis, so it is falling around 2.5. okay, so just check, I made a mistake, I'm sorry. So this is the current axis. Okay, so this is the current axis, left side. So initial current is 20 ampere and final current is 2.5 ampere. This is what you have to check. This is the final current, this is 2.5 ampere, and this is 0 to 10 hours. And initial voltage on this, it is 1.1 volt like this. So this point, this is 1.1 volt, and final voltage it is around 2.6 volt. Okay, like this. So this is the voltage graph, it is 2.6 volt. We have to take it up to 2 volt, but that 0.6 volt we are giving extra. Okay, so is this graph understood, all of you three? Can you just check, because there are two axes. This left side is the current axis and right side is the voltage axis. So I'll repeat again. So this side is the current axis. So this current is starting from 20 ampere when the battery was very less voltage, and the current is falling, 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 and current is coming here. So how to read this current? This current you have to read from this point. So if this is 0, this is 5, that means this current is 2.5 ampere. So when the battery is fully charged, it's having very less current, 2.5 ampere. When battery is very less charged, at that time current is maximum, it is 20 ampere. Now check the voltage. So this point, check voltage from here. This is the voltage axis. Okay, so initial voltage is this. So this on this axis is around 1.1 volt. So when battery is discharged, it is 1.1 volt. And when it is going top, when it is going here, totally charged, at that time the battery voltage is 2.6 volt. Likewise. Okay, is it understood by you? Can you just tell me, either saying yes, no, or just writing it in the chat box? Hello.
Yes, sir.
Okay, so don't mix up between the left side and right side of the scale. So left side is the current scale and right side is the voltage scale. So this is about constant voltage charging, and don't think this is constant voltage. This is how the battery is getting charged. This is how the battery voltage is increasing, but externally between two posts we are connecting 14.4 volt constantly. So that constant voltage you cannot see here. Constant voltage connected externally, but this is how the voltage of the battery increasing. Okay. Right side you can check. So two ways of charging a battery, showing the relationship between charging voltage and charging current. Right side you can find constant current charging. Here you can find this is the voltage graph. So voltage graph is increasing suddenly and it is staying there. So how much is the maximum voltage? Maximum voltage is between 2.22, so around 2.35. Okay, so each of this 2 volt inside the 12 volt battery, they are being given a voltage of around 2.35 volt. Okay, so this is the highest voltage. What is the lowest voltage? Lowest voltage is this much. Lowest voltage is this much, so it falls to around 2 volt or 1.75 volt. So this is the lowest point of voltage, and this is constant current charging. So constant the current is 40 ampere, and current is here. So here the charging almost it has gone up to constant voltage. It has, so during this part the voltage is increasing because current is constant. So this is a constant current charging. So current is constant as long as this time. So between, if from here to here it is 3 hours, if from here to here it is 3 hours. Okay, so this is around 1.5 hours, this is around 1.25 hours or something. So current is constant here. Current is constant of 40 ampere, and for certain time if the current is constant, the voltage is shooting up and voltage is getting stabilized. And what is the stabilized voltage? Around more than 2.2. So this point is 2.2, this point is 2.3. So there is around 2.375 volt. Okay, so as soon as the voltage is getting constant, then the current starts falling. So current is falling and current is almost becoming zero because the voltage has become stabilized. So when the voltage is very less, current is very high. When the current is very less, voltage is at its peak. So this is called constant current charging, because you can see the constant current here, which is flowing through the battery, and here it is constant voltage. This voltage, external voltage is 14.4, and the battery voltage is increasing from around 1.1 volt to 2.6 volt. And one very important line which was shown in the last slide: constant voltage is often the fastest way to charge a flat battery, and constant voltage is giving you higher voltage. Just check, this is a constant voltage charging. This is giving you almost 2.7 volt or greater than 2.6 volt, but constant current charging is giving us less than 2.4 volt. Okay, so constant voltage charging gives us higher charged voltage. So above graph show relationships among charging voltage and charging current during the constant voltage charging, constant current charging. Please prepare these two diagrams and mention the levels. Okay, in this theory the levels are not mentioned, that is what is the current level and voltage level in each case. In case of discharge state, and in case of charge state. So for constant voltage charging and for constant current charging. Roughly, you can estimate how much is the voltage and current maximum and minimum from these graphs, and you can write those values. So above graphs show relationships among charging voltage and charging current during constant voltage and constant current charging. And the boost charging is another method. Okay, so there's a popular technique often applied for many workshops, and you can check a battery charger for from Bosch, which is actually a boost charging. So boost charging is actually, you can check here, a rate of about 5 times of the normal charge setting will bring the battery to around 78 to 80% of its full capacity within approximately 1 hour. So here actually you are doing the boost charging, but not all batteries can handle boost charging. I told you previously that if you are charging, if you're trying to charge the battery very fast, we are actually losing the battery life. In short term, you might not see any performance degradation, but in long run, the battery will not be sustained or will not be having a longer life. Like when we are young, when we are maybe 15, 20, 22, 25 years of age, we are doing a lot of abuse on our bodies. So we are not doing exercises, we are eating a lot of junk foods, people are having a lot of habits and all these things, and you think nothing happens because my body is not having any pain or any problem. But actually that reduces our overall life, that reduces the overall longevity of our heart, lungs, kidney, and all those things. Same thing happens here. If initially you are charging the battery very fast, because we don't have time, we have to go to some place, and very fast we are charging the battery. So by boost charging, what, a rate of about 5 times of normal charge setting will bring the battery to 78 to 80%. Okay, we are happy with that, of its full capacity within approximately 1 hour. So you are actually supposed to charge the battery for 10 hours, but you are charging it for 1 hour with very high charging rate. In this case, the battery will get charged, you will be getting the performance, but the long life, that you will be losing. So it is a popular technique often applied to many workshops. It is not recommended as the best method because if correctly administered and not repeated too often, is suitable for most of the batteries. So in a very once in a while, in a very difficult conditions, totally your battery has become flat. Suddenly you want, in a very small time, you want the battery to be fully charged. Once or twice, once in a while, you can do that, but not frequently. You should use this boost charging method. The key to fast or boost charging is that the battery temperature should not exceed 43 degrees centigrade. A very important parameter. So this can be a short question, that during boost charging, what should be the temperature limit of the battery? It should be 43 degrees centigrade, because charging, if you are doing very fast, at that time it will generate a lot of gassing. Unnecessarily, it will generate a lot of temperature. But the temperature should not exceed 43 degrees centigrade. Intelligent battery charger, I will not be explaining it. It is actually automatically understanding how much is the battery charged now and how much rate it should be charged, so that it will be going to the maximum charge, and all the currents, voltages, and all those things. So here there is a microcontroller inside this. So there is a diagram. So this microcontroller actually checks what is the state of charge of a battery presently, and what is the best way. So some also have features such as recond mode, which allows us to correct the acid stratification. So stratification means there is layers or deposited in layers, acids and all these things. They are actually get deposited on the electrolytes. That should not happen. So that that often occurs in deeply discharged batteries, particularly leisure batteries. Leisure batteries means the battery which are not used very frequently. So key feature of a battery charger produced by CTEC. So CTEC is the company who is having this smart battery charger, and this battery chargers are able to determine the charging rate from the battery voltage and the current that it will accept. So there is a kind of intelligence that that is inbuilt inside the smart chargers, and it is safe. No spark should be generated. It can charge the battery up to 12 volt till 150 ampere hour. So just check, we are talking about battery of 44 ampere hour. Heavy duty batteries also having 44 ampere hour, but heavy duty batteries will be having higher reserve capacity, higher CCA. So those batteries also can be charged by using smart battery charger. So it's a connect and forget type of thing. So after it gets fully charged, it disconnects itself. So analysis mode is there. So sometimes for certain time, if we just connect the two probes with the post of the battery, this battery will analyze the battery state of the charge, and it will decide for how much time, how much charge is to be input to the battery for it to be fully charged. Supply mode can be used as a 12-volt power source to protect the electrical setting. So you can prepare a short note on this smart battery. So these are the battery charging methods. Again, I have put some 2 stars here. So constant voltage charging, it will be using 14.4 volt and will be for 10 hours. Constant current charging. So there are 3 ratings. 1/10 is for ampere hour, 1/16 is for RC, 1/40th is for cold start or cold cranking. Okay, and there is certain temperatures also mentioned. You please check it. Boost charging. This is only for 1 hour and will take the battery up to 70 to 80%, but it is not suggested for frequent charging. Okay, boost charging is once in a blue moon. You are in a very difficult situation. You have only very small time in your hand and you have to charge your car. Then only you should use boost charging. And smart charging, that is the last topic of the previous slide. That is, let the charger do all the calculation and all the work. So we'll just connect the charging between two posts and we will sit quietly. After the charging happens, the battery will automatically disconnect itself and will give us an indication. We have to just remove the battery. So what are the servicing things in the batteries that we are supposed to find out? So clean the terminals using hot water. The terminals are prone to corrosion. I told you previously. Terminals should be smeared with petroleum jelly or Vaseline, not only grease. Okay. So battery tops should be always clean and dry. If not sealed, then cells should be topped up with distilled water 3 mm above the plates. So these are the measurements we should be very careful about. 3 mm above the plates, we should put the distilled water. But this kind of battery is not used now. At present, only sealed batteries are used. They are maintenance free. The battery should be securely clamped in one position. So we should avoid all the different types of vibrations on the batteries. There are different kinds of faults that we are finding. So these are not directly in your syllabus, but yes, we should know about the battery faults. Okay, so the main fault is open circuit or short circuit. Open circuit means battery wants to get discharged, but there is some breakage in the wire and all, and battery is not able to supply. And short circuit means something happens in the external circuit and two posts are shorted. So the whole charge will be drained out in a very shorter amount of time, maybe in 1 second or 5 seconds, 2 seconds kind of time. And that will create unnecessarily current pressure or surge on the battery. So we have to avoid open circuit. We have to avoid short circuit by all means. Battery can also suffer from other problems. So often a problem with the vehicle battery can be traced to another part of the vehicle, such as the charging system. So car is not charging because car is not starting. Okay, the problem is not with the car. The problem is with the battery. So the battery problem surfaces elsewhere. Light is not getting turned on. Tail light is not getting turned on. So in that case, we have to check the battery, whether it is charged or it is able to supply. Ignition is a very big problem. If ignition does not occur properly, means we have to check the battery. So that's why it is said that often a problem with the vehicle battery can be traced to another part of the vehicle, such as the charging system. After this battery, we will be doing charging system tomorrow. So repairing modern batteries is not possible. Most of the problems related to batteries will require the battery to be replaced. That is nowadays battery. In case of sulfation, so this is another definition you have to prepare. What is sulfation? It is sometimes possible to bring the battery back to life with a very long low current charge. Okay, so if sulfation happens inside the battery, very long, maybe 20, 30, 40 hours low current charging will remove sulfation to some extent from the battery. A 40th of ampere hour capacity or a 1/200 of a cold start performance for about 50 hours in an appropriate rate. So there's the same thing. How can we avoid sulfation, or if sulfation has happened, we can restore the battery by reducing the cold cranking as well as reducing the ampere hour charging. So very small current for very long period of time. If we connect to the battery, constant current charging, sulfation can be avoided. Now we will come to know about the most important thing, that is called a hydrometer. So almost all vehicles are now fitted with maintenance-free batteries. Hydrometer, which is used to test the non-sealed batteries. So previous days I have seen that hydrometer. So hydrometer cannot be used nowadays present battery because they are sealed. But in old batteries we could use hydrometer to understand what is the state of charge. So for sealed batteries, SOC is to be determined from the voltage of the battery. A voltmeter is required for the same. So this is a slide I have prepared. I will not be explaining it. This is slide number 10. I'm leaving it up to you. Please go through that. So only thing I'll tell you, so there used to be some kind of holes, and this is a hydrometer. Used to put that hydrometer through that hole inside the water electrolyte, and if it is giving 1.110 to 1.130 rating, the hydrometer, in that case it is totally discharged. If it is giving 1.230 to 1.250, this is the ion concentration level or something, it is 70% charged. If a hydrometer is giving 1.27 to 1.29, that means the hydrometer is totally charged, that is, it is equivalent to 2 volts. So the hydrometer comprises a syringe that draws electrolyte from a cell and a float. So this is the float thing that will float at a particular depth in the electrolyte according to the density. So more is the charge, the float will be lower, and less is the charge, the float will go higher. Fully charged cell should show 1.280 to 1.2, so 1.270 to 1.290. Okay, and discharged cell will show 1.130. Okay, this is a reading in the hydrometer. List of the common problems encountered with the lead acid battery together is shown here. So what are the main problems in case of lead acid battery? So low state of the charge and likely causes are given here. So who is causing low state of charge is given here. Low capacity. So whenever I'm saying low capacity means voltage has become low. So this will be indicated by low SOC, corroded terminal. Okay, sulfated impurities in the electrolyte, old age active material, likewise. So overcharging if you are doing, this will create excessive gassing and temperature. Okay, so overcharging always you should avoid, because more will be the gassing, less will be the efficiency of the battery. Short circuit, how the short circuit happens? It happens through damaged plate on or insulator of active material in sediment trap. So these are the causes for short circuit. Likewise, you can just check what are the different battery testing procedures. So these are the checking of battery voltages. So this is called DMM or digital multimeter. Inside that there is a voltmeter, and in that voltmeter, so these are the two posts. So this is positive, negative. We are just connecting and we are finding the charge to be 13.7, should be greater than 12 volt. So the engine had just been switched off so that the reading shows surface charge. Okay, so the battery, if you just allow it to cool down a bit just after stopping the car, maybe half an hour or so, then it will show you 12 volt, the latest batteries. But just after the switching off of the battery, if you just check, it will be showing you a lot higher voltage than 12 volt, because there are a lot of surface charge. You can go through Google what is the surface charge. So battery voltage reading and SOC. So if it is 12, then it is discharged or 20% less. If SOC is 12.3, half discharge. If it is 12.7, it is fully discharged. Oh, sorry, it is fully charged. Okay, likewise. So this is for modern day battery, and previous slide whatever I had shown, it was for olden days batteries. So present day battery, 12 volt means it is discharged, 12.3 it is half discharged or half charged, 12.7 it is fully charged. Okay, so the terminal voltage of a standard lead acid battery must not be allowed to fall below 1.8 volt. So each of the small 6 batteries, highest voltage is 2 volt, lowest voltage should not be less than 1.8. However, some batteries are designed to allow dip discharge. Okay, but normal Bosch batteries of 12 volt, minimum voltage should be 1.8 at full discharge. All batteries suffer from self-discharge, which means that even without an external circuit, the SOC gets reduced. So I explained this thing to you long back, that if you're just keeping the battery and not driving the car for a long time, you'll find that the battery voltage has fallen below 12 volt. So these are safety precautions: good ventilation, protective clothing, supply of water, first aid equipment, and no smoking near the batteries. Finally, we have come to the end topic, which is called as a alkaline battery. You can go through this. What are the positives of alkaline battery? They are maintenance free. Alkaline battery is required to withstand a high rate of charge and discharge on a regular basis. So lead acid battery, whatever was shown previously, not possible, but this alkaline battery, they can withstand high rate of charging and discharging. So these are some disadvantages of lead acid battery, which will be the positive points for alkaline battery. Alkaline cells, on the other hand, require minimum maintenance. These cells are far more able to withstand electrical abuse. Electrical abuse means fast charging and discharging. Overcharging also can be withstood by the alkaline battery. But the disadvantage of alkaline battery are that they are more bulky, have lower energy efficiency, and are more expensive than the lead acid batteries. This is again positive. So generally positives I have given in green, negatives I have given in blue. Okay. So when the lifetime of the battery and servicing requirements are considered, external initial cost of alkaline batteries is worth for some applications. Bus and coach companies and some good large goods vehicles operator have used alkaline batteries. So what is the change in alkaline battery? This is very important. So in case of previous alkaline battery, they used to use nickel cadmium. Nowadays we are using nickel cadmium, and NiCad batteries do not offer overcharging, because once the cadmium oxide has changed to cadmium, no further reaction can take place. So automatically this will stop the overcharging. This is a internal property of this slide. So this slide is very properly readied. The same thing you will find in your book. So if you're just going through the slides and if you're having any doubt, you can ask me. So this is the 13th slide, and one very important other detail. Cell voltage of a fully charged cell is 1.4 volt, but this falls rapidly to 1.3 volt as soon as discharge starts. So you can charge the alkaline battery maximum up to 1.4. As soon as the discharge starts, it falls to 1.3, and at complete discharge it is 1.1. Okay, so these are the small details which will be asked as a short question. Please remember. And this is our last slide, and what we have given is these are the reaction things. So which is the positive plate? It is nickel hydrate, NiOH. What is the negative plate? It is cadmium, given by CD. Main components of nickel cadmium cells. So this is another diagram you can produce in the exam. So you can see here the black things, they are actually the negative plates, and the white things in between, they are actually positive plates or nickel hydroxides. And there are certain electrolytes. All these things are submerged into electrolytes, and electrolyte is nothing but water and potassium hydroxide. Okay, so this is a simplified representation of a NiCad alkaline battery cell. The process of charging involves the oxygen moving from the negative plate. So from all these black negative plates, oxygens are moving, and the reverse when discharging. So oxygens are absorbed by these negative plates when discharging. When fully charged, the negative plate becomes pure cadmium. So all these dark plates, they become pure cadmium, and the positive plates become nickel hydrate. So these white plates, white positions, so you can check it's a series of positive and series of negative. So here around 1, 2, 3, 4, 5 plates of negative and 4 plates of positives that are there. So the 2H2O, so what are actually the output? So you can check here, this KOH, potassium hydroxide, does not get changed. So previously also it is potassium hydroxide. The water, they act as the electrolyte. So when fully charged, the negative plate becomes pure cadmium, and the positive plate becomes nickel hydrate. A chemical equation to represent this reaction is given below. Only this one reaction you can represent in the final exam. The 2H2O, that is the water, is added as hydrogen and oxygen. They are not added as water, but in gaseous form, hydrogen, oxygen, and always as gases. Okay, and this gassing also is taking place during the discharging. So all those things are stored and again reused. Water usage by the cells indicate that the cells are in operating condition. That means if the cell is continuously using water, that means that the cell is active. It is producing some kind of energy. Electrolytes remain unchanged during reaction. So that is what KOH is remaining unchanged during reaction. So relative density reading does not indicate SOC for the battery. So we cannot directly get SOC reading for the battery. These batteries do not suffer from overcharging because we told you previously that as soon as the oxide starts forming, the reaction stops. Okay, because once the cadmium oxide has changed to cadmium, no further reaction takes place. Okay, in the previous slide also it was shown to you. Here it is explained that NiCad battery do not suffer from overcharging because once the cadmium oxide has changed to cadmium, no further reaction can take place. So this is a positive of the battery. This is a diagram, reaction, and this is how the electrolyte behave and what is the positive point of the battery. So this finishes actually the total battery part. That is the first topic from the first module